Hi and welcome back to episode 19 of polishing this turd. Doing a complete overhaul, modification, restoration on this Sieg 7x12 mini lathe. Now need to assemble everything. Paint's pretty much dry now, so it's time to reassemble. First up, let's just get it roughly leveled. Unfortunately, my precision level isn't here at the moment. Lent it to a friend, so I'll just do a rough level with a normal woodworker's level at this stage. At the moment, I've just got the threaded studs. It's just sitting straight on the floor, but I think I'll buy a set of hockey pucks and sit them down on that as kind of vibration isolators. It still needs to come up a ways. That's now roughly level in both directions. I'll have to do a fine tuning once it's all set up, but before I do that I'll get the feet for it. So next up, let's get some cabinets installed. So let's install this cabinet. There used to be paint on this inner surface, and in fact there are still a few bits where I couldn't get to it easily, but really there's not a lot of point having paint on the inside of a enclosure for a CNC machine. All you need is one rat's nest of especially stainless, and it just rips the paint to shreds. So I decided just to sand the paint away, and I'll just put a bit of wax or something on it just to stop it from rusting. Although things don't rust too badly in my basement anyway. Okay, well that kind of goes against exactly what I was just saying, because I then painted the stand, but oh well. Nothing like being inconsistent. The rear mounting hole needs a hole through the top of the cabinet. So one thing that's kind of driven me nuts for the last couple of weeks is having all my parts of the mini lathe stacked up in ice cream containers on my bandsaw. Yeah, just kind of messy. Always in the way. Fun fact, New Zealanders have the highest consumption of ice cream per capita in the world. Of course, I don't need patrons or sponsors or anything because I'm sponsored by Eskimo. Really, we're quite lucky that the mini-lathe projects even gets this IKEA chest of drawers, because I could have just made something out of a whole bunch of ice cream containers. So now I've got a good place to store all the lathe junk until I actually need it. Thanks a lot for the comments I'm getting from you guys. How many original parts do you have left in this? Oh man, original, like unmodified? None. How many parts from the original machine are still even used? Well, the bed, I guess the headstock casting, spindle, that little cover on the back, the saddle, nothing in the saddle, no apron, no lead screws, and I guess the castings for the tailstock. That's it. Everything else got deleted, replaced, improved upon, hopefully. Yeah, a number of you commented on the use of the IKEA cabinet of drawers. Andy Jenkins uses, I think, what he said 3 sets in his woodshop, and suggested putting in a piece of MDF into the bottom just to sort of stiffen them up a bit, which is a great idea. You can glue the back in. You can't really add any glue to this front sheet because it's really just very thin sheet metal, edge on edge, so there's not much gluing capability. So good idea. I'll probably get some MDF cut to size and then glue those to the bottom. That's more like it. With all that junk cleared away, I can now use the dual for its intended purpose, assembly bench. Now it's probably overkill, but since I've got some, I'm going to be packing the main spindle bearings with Kluber. This is about as good a bearing lubricant as you can buy. I think I got it on eBay. I'm going to put a link up here in the corner to a video by Rob Rensetti on how to properly pack spindle bearings. I mean, he's talking extremely high precision bearings. These here are just, I think they're SKF Explorers. They're nothing that special. For a high precision, high speed spindle, he goes to a lot more trouble than this to actually make sure that the grease is perfectly packed down in, amongst the bearings. There's been some discussion in the comments section about sealing this head casting and running these gears with oil, which realistically would be a very good idea, because I'm a little concerned that they're going to be so noisy, it'll be horrible to operate. And the second thing I'm worried about is that they're going to wear out too fast. Sealing this head casting is not going to be something trivial. On the one hand, obviously you'll need to put some sort of a floor in here to seal it, but then you're going to need to cut a window somewhere else in the side so that you can actually insert the gear as the shaft goes through. You're also going to need to have some sort of a solution for a seal on the change lever port and the 2 lower shaft bearings, and I guess the whole thing to me is just not worth it. I'll just accept that it's probably going to be noisy. My guess is these gears aren't going to last forever, but let's be honest guys, they cost $45. This machine's probably only going to be used for a few hours a year maybe. The bollie's still going to be my primary lathe, I think. I'll just live with it. If these gears wear out, I'll either buy new ones or just replace the whole drive mechanism back with a direct drive pulley and put a bigger motor on the lathe. Yeah, before you start wailing on bearings with a hammer, you know, it's easy enough to make up a spindle press like this. This is just an old piece of tube, a couple of bits of all thread. Didn't have one long enough, so I just connected them with a long nut. You know, basically just the parts out of the clamping box. Now to center this gear on the shaft, originally there were 2 plastic spacers. I've replaced them with a pair of aluminium spacers I turned up. So we need to line that up with a keyway. Back spacer goes on, back bearing, and the whole thing can be pressed together. Just put a steel tube over to press against the bearing. A 1, 2, 3 block under there gets it pretty much on center height, and then it's just using a wrench to seat the bearing. Oops, first scratches in the paint already. Back when I first did a bearing change years ago, I didn't undo those 3 screws on the front dust cover before I pressed out the spindle, so I basically pressed the spindle through the plastic cover and destroyed it. There was originally a key here to drive the change wheels, I guess. I didn't bother putting a key onto the drive pulley for the spindle encoder because there's almost there's basically zero load on this. All it's doing is spinning an encoder, which has very low friction. I'll just use this piece of wood across the 4-jaw chuck to lock the spindle as I seat the bearings. The next assembly to go in is going to be the intermediate shaft for the with the drive pulley and drive gears on it. And for this I've got a new pair of bearings. These are SKF's fully sealed bearings. I'll grease this with just normal wheel bearing grease. That's the low gear. It's got a bit of a graunchy feel to it. Through here, goes tight, then goes loose again. Feels almost like the gear teeth are not concentric with their own shaft. Well, I guess we'll install it, run them in and see what happens. This is the gearbox changing dog. With the spindle installed, I figured that before I do anything more, I'll bolt the headstock down to the bed, fit the test bar and just see whether this is still nice and straight or whether I've managed to pull the bed out of alignment by mounting it onto the stand. In the horizontal, it's looking fantastic. This is my most accurate indicator, measures 1/10,000th of an inch, and it's basically pretty much zero. Maybe 1/10th of drop along the length of it. Very nice result. I was asked whether the whole table will stiffen things up, and I very much doubt it, so let's have a look. Yeah, no. Can still easily twist the bed by a whole 1/1000th of an inch or more, just with a bit of pressure. Looking now at the vertical alignment, it looks like I've got about 5/10,000th of an inch, so half a thou of run out over, oops, I bumped it, over 8 inches, and the standard according to Connolly is 1 thou over 12 inches, so I'm also here within the standard. Not as good as the horizontal alignment, but acceptable. Next up, I'll be mounting the motor. When you design something, guys, try and make it easy to assemble. This isn't. Unfortunately, I can't get that fourth that fourth nut on very easily. So I'll take the plate off the bottom first, bolt the the motor to its mount, and then once that's done I'll screw the mount down to the table. When I paint the tailstock, I better remember to paint this thing as well. This cover looks terrible. I'll temporarily mount the spindle encoder and also the Z-axis motor, because I need to work out where the hole goes somewhere in this area for the cables to drop down into the electrical cabinet. Before I move on with anything, I would like to just connect up the inverter and run the motor and just make sure everything's going to work okay. Here you can see I've clutched up some power to the inverter. It's powered up with a error code, no operations. That's probably tied in with the way I had it set up before, where I was just using an external switch and an external pot to give me my speed control. So I'm probably going to have to find the setting which returns it to the front face connections, and luckily for that I do have the manual. So let's do a little RTFM, shall we? Well, that manual is useless. That's just the instructions for how to connect the electrics. I think I've got a different programming guide somewhere. I've connected the VFD to the motor. I've connected the VFD control inputs to this switch for forward and back. It's reverse and forward. And then this pot is the speed control. Yeah, running it between 10 Hertz and about 83 Hertz, 85 Hertz. So that's in the high speed setting. Let's try the low speed setting on the gears. Well, there's definitely a lot more torque than there used to be with the original Sieg setup. You know, those gears are pretty darn loud. I think I'll let them bed in later. I'll also have to see how warm the bearings get, but that's the motor installation working, which is good. Yeah, I can definitely bog down the spindle in the high range, much more than in the low range. So now we get to that part of the build where every decision you make affects every other decision. Basically, I'm going to have power coming in from this side. I want it going to these terminal blocks at the bottom so that I can break off multiple, for example, 240 volt legs, because I've got to power here the VFD. On this side I'll be powering the main 24 volt DC power supply. There's going to be like this sort of cable control channel running up the middle. In fact, I'll do that over both cabinets. So it will also run up through the middle of this one. I'm going to put the holes with cables coming out to the machine pretty much down the center line here, so they'll just go straight out. One issue I have is that this stepper drivers are very, very deep. Now, if I mount the back plane for this cabinet in its normal position, I'm not going to have enough space to close the door. So I'm going to have to just make a couple of spaces to move that back closer to the wall. That's not going to be a problem. But I really need to get these steppers mounted with their cage before I can do anything permanent running up through the whole cabinet. So yeah, I guess in the cabinet doing this is probably one of the first jobs. So what I'll do is switch to something completely different, and that is finish the enclosure. There's a few little bits and pieces I still need to do on this enclosure before I can nail it all together. So I think I'll leave it there for this week and get this video edited and uploaded. Once again, thanks very much for watching, and I look forward to seeing you again next week.